Hello, hi and namaskara. My name is Kirtan and I am a second year medical student studying in a government medical college. Today I will be talking about the second part of the cardiac cycle video. The first part I have already uploaded. So before starting this video, if you haven't subscribed to my channel, please subscribe for more informative physiology videos like this. So in this video, we will be talking about the pressure-volume relationship in the cardiac cycle and also about the heart sounds. So let's start. The pressure-volume relationship. It has four phases. The phase 1 is the period of filling, that is from the point A to the point B. This is the graph of the pressure-volume relationship in the cardiac cycle. So the phase 1, it starts at the point A, that is opening of the mitral valve. So from the opening of the mitral valve, it ends at the closure of the mitral valve. So this is the period of filling or the diastolic filling of the ventricles. In this, the ventricular volume increases without significant change in the pressure. So initially, the ventricular volume will be 50 ml. This is the end systolic volume. This means that after systolic phase, some amount of blood remains in the ventricles. So this is called the end systolic volume. That is 50 ml. So 50 ml remains in the ventricle after systole. So the diastolic filling happens for 70 ml. So 70 ml plus 50 ml, it gives 120 ml in total. So 120 ml is filled in the ventricles. So the graph moves here. It ends at B, point B, that is closing of the mitral valve. So there is no significant change in the pressure here. The next is phase 2. This is the period of isovolumic contraction. The volume will be constant in this because the valves in the heart are always closed in this phase. So all valves are closed in this phase. So pressure in the ventricle increases up to 80 mmHg. It ends at C, point C, that is opening of the aortic valve. So the volume of the ventricle remains constant and the pressure increases in this. So this is isovolumic contraction. So next comes the period of ejection. This is from point C to D, and from D to E it's rapid phase of ejection is from C to D, and from point D to E it's slow phase of ejection. So the phase 3 is period of ejection from point C to E. There is decrease in the ventricular volume. The ventricular pressure rises till point D. Here it rises till point D because the ventricle contracts drastically in this rapid phase of ejection, but the ventricular pressure decreases here than the aortic pressure. So this is the slowed phase of the ventricular ejection. So then it decreases till point E. So after coming to the point E, there starts the phase 4, that is period of isovolumic relaxation. So in this also the volume will be constant. So the ventricular pressure drops to equal diastolic pressure. So it equals the diastolic pressure and it reaches the point A. So this is the main graph. You should draw this graph in the examination if this question is asked and mention these points according to the phases. Now let's talk about the heart sounds. There are mainly two heart sounds, that are first heart sound and the second heart sound. Many other also heart sounds are there, that are third heart sound, fourth heart sound and triple heart sound, which are not important. The first heart sound and second heart sound can be asked in the board examination. So let's discuss about them. The first heart sound is also called as the S1 sound. It is due to the sudden closure of the AV valves, rushing of the blood due to the ventricular contraction. Rushing of the blood causes the turbulence of the blood, which also contributes to the heart sound, and increase in the tension in the ventricular muscles due to the contraction. So these are the reasons due to which the first heart sound can be caused. So what is the significance of the first heart sound? It is the beginning of the ventricular systole and the AV valve closure. So what is the duration of the first heart sound? It is 0.15 seconds. And what about the frequency? It is 25 to 45 Hertz. So talking about the significance, there is accentuation of the first heart sound in cases of exercise, hypertension and cases like anemia. And there is diminution of the first heart sound in the cases of shock, acute myocardial infarction and emphysema. So you need to remember at least three factors which cause the accentuation of the first heart sound and the diminution of the first heart sound. Accentuation of the first heart sound means nothing but that the increase in the sound in the first heart sound, and diminution means the decreased sound of the first heart sound. So the next one is the second heart sound. It is also called as the S2. So it is due to the closure of semilunar valves. So also rushing of blood in the ventricles contribute to this. So here in the first heart sound is the rushing of blood due to the ventricular contraction. So this causes turbulence. In the second heart sound is the rushing of blood inside the ventricles, because the AV valves will be open here. So rushing of the blood in the ventricles will also contribute to the second heart sound. So what is the duration of the second heart sound? It is 0.12 seconds, and the frequency, it's more than the or double than the first heart sound, that is 50 Hz. So what is its significance? It signifies the end of the clinical systole and also the closure of the semilunar valves. So the loud A2, A here means the aortic component. See, semilunar valves means the aortic valve and also the pulmonary valve. So it can mean both. So here A means the aortic component and P means the pulmonary component. So the loud aortic sound, aortic component of the semilunar valves will be seen in the systemic hypertension and the aortic dilatation, and the loud P2 or the pulmonary component of the semilunar valve will be seen in the pulmonary hypertension and pulmonary arterial dilation. So hypertension and dilation are same here, only the aortic and the pulmonary name changes. The diminished A2, it will be seen in cases of aortic stenosis and aortic incompetence. Stenosis means nothing but the narrowing of the blood vessel, narrowing of the aortic part. You can imagine like that. The diminished P2 means occurs due to the pulmonary stenosis. The stenosis is common again here in both of this. Only the aortic word changes. Next comes the concept of the splitting of S2 or the splitting of the second heart sound. Because the second heart sound contains both aortic component and the pulmonary component, there can be splitting in that. The splitting is also seen in the first heart sound. It is also seen in the first heart sound, but it is not much prominent. So splitting is not prominent in the first heart sound because the frequency or the amplitude of the first heart sound will not be much than the second heart sound. So it cannot be heard normally. But if this is heard in the first heart sound, if the splitting is heard in the first heart sound, it is due to some pathological conditions. So what do you mean actually by splitting? Splitting is nothing but the gap in the aortic component and pulmonary component of the second heart sound. And similarly, the gap in the mitral valve and tricuspid valve splitting is seen in the first heart sound. So the gap in the aortic component and pulmonary component of heart sound is known as the splitting of the S2. So why is this splitting actually caused? It is caused due to the many reasons. So one of the reasons can be it is increased in the inspiration process. So during inspiration, the right ventricular volume will be increased due to the increase in the thoracic blood volume. So during inspiration, the thoracic blood volume will increase. So therefore, it will increase the right ventricular volume. So when the right ventricular volume increases, it has to pump more blood to through the pulmonary valve. So the pulmonary heart sound will be delayed. So because more volume of blood is there, the pulmonary heart sound will be delayed because the pulmonary valve takes more time to close. So there is gap between the aortic component and the pulmonary component. So this is one of the reasons for the splitting of the S2. So the splitting of the heart sound is normally observed in children's. Normally observed in children and rarely observed in elderly adults. So this is for this video. If you like this video, please like, share and comment, and also don't forget to subscribe. I'll provide the notes for this video in my Telegram channel. You can follow the Telegram channel. I'll upload the link in the description below. Thank you.